Welcome to the second part of your lecture, in which we will continue discussing World Wide Web. In this part, we will discuss the Hypertext Transfer Protocol, HTTP. HTTP is an application layer protocol that runs on top of TCP. HTTP is becoming like more transport protocol that provides a way for processes to communicate and send contents across the boundaries of different networks. These processes don't have to be web browser and web server. They can be a media player using HTTP to talk to the server to require album information, or antivirus software uses HTTP to download the latest. There are various uses for HTTP, such as developers can use HTTP to fetch project files. Consumers of electronic products like digital photo frames often use embedded HTTP server as an interface to the outside world. Machine-to-machine communication increasingly are running over over HTTP. For example, airline server might use Simple Object Access Protocol, SOAP, and it's an XML RPC for HTTP to connect with a car rental server and make car reservation, all as a part of a vacation package. These trends are likely to continue along with the expanding use of HTTP. HTTP connections, methods, message headers, and caching are to be discussed. HTTP has three types of connections. Version 1.0 has multiple connections where it establishes the TCP connection for each part of the page it's actually requesting, sending a request, getting a single response, terminate the TCP connection. Version 1.1 has persistent connections. It established a TCP connection, looping to send requests and getting single responses. Terminate the TCP connection. Version 1.1 also has persistent connection with pipelines, as we shall see. Here in figure A, there are multiple connections and sequential requests using version 1.0. Using version 1.1, there can be multiple requests during the same connection without terminating the connection. Using slow start, there can be pipelines to send multiple requests and get multiple responses. HTTP has methods because it was originally designed to support object-oriented programming. These messages, the main messages we're going to discuss is GET, that is a request to get a web page, HEAD, a request to get a web page header, PUT, request to store a web page, POST, append to a named resource, for example, a web page, delete to remove a web page, trace to echo the incoming request, and connect, this is reserved for future uses. Options, these are query certain options. Each request consists of one or more lines, with the first word of the first line being the name of the method requested. The method name is case sensitive, so get in capitals is allowed, but get in small is not allowed. The get method requests the server to send a page, where the head method requests the server to send the header of the page only. This can be for collecting information, for indexing, for example, or for web searches, or just to test the URL validity. POST method is used in form submitting both, and GET is also used for SOAP web services. It uploads data to the server. POST, it uploads data to the server, the contents of a form in RPC parameters. The server then does something to the data in that URL, conceptually appending the data to the page. Finally, the method returns a page indicating the results. PUT method is the reverse of GET. Instead of reading the page, it writes the page. The method makes it possible to build a collection of web pages on a remote server. Delete is deleting a page from a web server, where trace method is used for debugging. It instructs the server to send back the request to see if there is something wrong with the request. Connect method lets the user make connection to a web server through an intermediate device such as web cache, but it's not used yet. Options methods provide a way for the client to tell the server, to ask the server for a page to obtain methods and headers used for that page. The HTTP methods has status code for responding to the requests. 1XX means information. For example, 100 server agrees to handle the client request. 2XX indicates success of the request. 200 request succeeded. 204 no content to present. 3XX is redirection. 301 is page has moved. 304 cache pages are still valid. 4XX for client error. 403 forbidden page. 404 page not found. 5XX server errors. 500 internal server error. 503 try again because the server is busy. Request lines like the line with get method may be followed by additional lines with more information. This information is called request headers and can be compared to parameters of a procedure call. Responses may also have response headers. Some headers can be used in either direction. For example, user agent that will tell the server the information about the browser and its platform. Accept will tell the type of pages the client can handle. Accept character set will tell the character sets that the client can accept. Set cookies is for setting cookies on the client. Server is information about the server. These were requests and responses. Date, indicating the date the message was sent. A range, indicating the portions of the page. Cache control, the directives for how to treat the cache. These are sent in both ways. HTTP has built-in caching support for better performance. The question here is how to determine that the previously cached copy of the page is the same as the page that would be fetched again. There are two strategies. The first one is page validation, and that is the cache is consulted if it's a valid copy of the page or it's not valid. The validity here is determined by the expiry time set by the server upon sending the page. The second strategy is to ask the server if the cached copy is still valid. This request is called conditional get, and both caching strategies are override by the directives carried in cache control header. As we can see here, we have the two options. The request is sent. Instead of sending the request to the server, it's sent to the cache. The cache will check the expiry of the page. If it's not expired, it's still fresh, it will send it back to the user as a response. If the page is expired, it will send a GET request to the server, where the server will return the page to the user. Otherwise, the cache will consult the server sending conditional get. If the page was not, the cached page was not fresh enough, the server will send a response with a new copy of the page, and this will be sent to the user. If the page was fresh, then there will be notification that it has not changed, and the cached page will be sent to the user. The last part of our World Wide Web is mobile web. There are difficulties with mobile phones or mobile devices in general in browsing the web because they have relatively small screens, limited input capabilities, network bandwidth is limited for them, connectivity might not be continuous, and computing power is limited by battery life, heat dissipation, size, and other factors. The first attempt to build a mobile web protocol stack was WAP, and it has failed miserably. Then iMod, and it was successful only in Japan. Then WAP2, it was rather useless. If there is any need for a new protocol stack, no, because all the factors we have said, the small displays are getting larger, the limited capacity of processing is getting better, the connectivity is more stable, the bandwidth is much higher now, so no need for a new protocol stack. Yet we are going to study these protocols. WAP protocol stack has 6 layers, wireless application environment on the top, then wireless session protocol, wireless transaction protocol, wireless transport layer security, wireless datagram protocol, and last viewer layer that can be GSM, SIGMA, and so forth. WAP architecture is not that complicated, where a WAP-enabled mobile device will connect the base station. The base station will connect a WAP gateway through a router. The WAP gateway will connect a translation server that translates WML requests to HTML requests. And then the HTML requests are sent to the web server through the internet. The web server will reply with WML web pages sent to the WAP gateway, back to the base station, to the WAP-enabled device. The iMod, on the other hand, has a much complicated architecture where there is iMod handheld device connected to a base station. The base station is connected to voice to network router that is connected to a protocol conversion gateway. The protocol conversion gateway is connected through a TCP connection to the iMod server. The iMod server is connected with a lease line to the service provider, and the service provider is connected to other service providers from the official menu. These service providers are connected to the internet, and then the response will be sent back to the protocol conversion gateway through a TCP connection, back to the voice to network server, to the base station, to the handheld device. If you want to compare WAP to iMod, some features are WAP is a protocol stack where iMod is a set of service. WAP supports handsets, PDAs, notebooks, while iMod supports only handsets. WAP access uses dial-up, where iMod is always on. WAP uses circuit switched. iMod uses both circuit switch and packet forwarding. They both have the same data rate. WAP provides monochrome screen, while iMod provides color screen. WAP uses UML, WML markup language, while iMod uses CHML markup language, and so on. As you see, these differences represent the history of mobile devices. Now things are completely different, and the TCP/IP protocol suite is supported by the mobile devices. WAP 2, on the other hand, has push model as well as pull model, not as WAP 1. It supports integrating telephony into apps. It supports multimedia messages. It includes 246 and 64 pictograms. It has an interface to storage device. It supports plugins in the browser. It supports 2 protocol stacks, the old WAP.1 protocol stack and the TCP/IP protocol stack. Our last topic for this lecture is web searches, and that would be your writing assignment for this week. There are major web companies that provide searches like Google, Yahoo, Microsoft Bing, and Baidu in China. How does the web search works? How to find pages, web crawling, how to store pages, hard disks, how to process web pages, indexing, how to make profit from them, advertising. And you shall know more about it as your writing assignment. Your reading assignment for this week is section 7.4, 7.5, chapter 7, Computer Networks, Andrew Stewart Tannenbaum. Your writing assignment is web search, and see you in the next lecture. Thank you very much.